Good morning, dear friends. So, this is video lecture number 3 of Newton's laws of motion. So, in the previous two lectures, we discussed about inertia, what is force, types of force, effect of forces, inertia, types of inertia, inertia of rest, inertia of motion, inertia of direction. Now, the most important things is Newton's laws of motion. So, one by one, I explain all the Newton's laws. Basically, it is of three types: Newton's first law, Newton's second law, and Newton's third law. So, open your notebook and write Newton's first law of motion. Newton's first law of motion. So, what is Newton's first law? That if a body, an object at rest, tends to stay, tends to stay at rest, and an object in motion tends to stay in motion, stay in motion with same speed, with same speed in the same direction, the same direction, unless it is compelled by some external unbalanced force, unbalanced force to change that state, to change that state. Okay, or we can simply say if a body is in rest or moving with constant speed, then it will remain in its state of rest or motion until and unless an external force is applied on it. Okay, so this concept is clear. Okay, suppose a body is in rest, then it will remain in its position until and unless an external unbalanced force not applied on it. Okay, so if a force is applied on a rest motion body, then it produces rest, or object in motion, then object in motion. Okay, so both the points is clear to all of you. So Newton's first law, I think, clear to all of you. After first law of motion, it is very compulsory to know that what is linear momentum, because it is basically based on the Newton's second law of motion is purely based upon the linear momentum. So open the notebook and write the second heading, that is linear momentum. So linear momentum can be defined as, it is defined as the mass in motion. It is defined as mass in motion. Okay, mass in motion along a straight line path, along a straight line path. Okay, or the second definition, which is basically based upon the formula. So momentum can be defined as the, it is defined as the product of mass and the velocity of the body, and the velocity of a body full stop. Okay, so both the definitions clear to all of you. So now what is the formula for linear momentum, how it is represented? So it is basically represented by small p. So small p equal to mass into velocity. Okay, so mass into velocity, that means p equal to m into v. P is a vector quantity. Unit is SI unit, mass is kg, and velocity is meter per second. So this is unit is kg meter per second. If we're talking about dimension, so dimension is m l t minus. Okay, so m l t minus. So momentum definition, momentum formula is clear to all of you. Now momentum is basically based upon the mass and velocity both. So if condition arises that if both the body is moving with the same direction, now condition arises if both the body is moving with same speed or velocity, then find the ratio of their momentum. Then find the ratio of their momentum. Okay, so P, it is written P equal to M into V. So we can say P1 upon P2, that is M1V upon M2. So V2 we cancel. So P1 upon P2 equal to M1 upon M2. So the body which is heavier mass, if M1 is greater than M2, then also P1 is greater than P2. So a body heavier mass have larger linear momentum as compared to smaller mass. Okay, so heavier mass body contain or has a larger linear momentum. Larger linear momentum. Okay, so heavier mass body has a larger linear momentum. This point is clear to all of you. Dimension is clear, vector quantity is clear. Now, what is change in linear momentum, or if we represent the graph? So here are some important graphs. Suppose This is y-axis and this is x-axis. Also y-axis and this is the x-axis. So there are basically three graphs. So y-axis and this is x-axis. We all know the formula for momentum, that is P equal to m into v. P equal to m into v. So here are three quantities, that is momentum, mass and velocity. So if the graph is between momentum and velocity, then the third quantity is constant. If this graph is P and V, momentum and velocity. So momentum is directly proportional to velocity, so the graph is like this. Okay. If we are talking about momentum and mass, then also the graph is like this. If I am talking about momentum and mass, momentum P and mass, when velocity equal to constant, and in the first graph mass equal to constant. Now the third graph, that is P1, that is velocity and mass. If velocity is represented in y-axis and mass is in x-axis, so P equal to constant in this case. So if P equal to constant, then mass or velocity is direct inversely proportional to mass. If velocity is inversely proportional to mass, then the graph is like this. Okay, so velocity inversely proportional to mass. So I think Newton's first law and linear momentum is clear to all of you. Okay, students. Bye bye. Take care, all of you.